Good afternoon, class. We are looking at pre-calculus, chapter 8, further applications of trigonometric functions, section 8.2, the law of cosines. So the objectives for section 8.2, the law of cosines, are solve SAS triangles, solve SSS triangles, solve applied problems. SAS, side, angle, side, SSS, side, side, side. Reminding you of properties of trigonometric functions. Trigonometric functions in essence follow the unit circle, point having coordinates x comma y, or cosine t sine t. Sine represents y, cosine represents x, tangent is y over x, and the rest of them follow in the same manner. All trigonometric functions are odd except cosine and therefore secant. Fundamental identities such as Pythagorean identities, quotient identities, and reciprocal identities are discussed. When it comes to a right triangle, a squared plus b squared equals c squared, also Pythagorean theorem. A plus b, they must add up to 90 degrees because one angle is 90 and the total interior angles must be 180 degrees. So the law of sine, we have various forms. The bottom line is the sine law indicates sine A over A, sine B over B, sine C over C. They are identical. And in the first case, ASA angle, side angle, or side angle, angle, we have one side and two angles, and we get one unique solution and one unique triangle. SSA, that means side, side angle, two sides and an angle. Opposite one of them could result in several different situations, and that's why it's called an ambiguous case. Consequently, SSA is called an ambiguous case. So various things happen. Okay, this is an acute angle. If A equals H, we end up with one triangle, which is a right triangle. If A is larger than B, larger than H, then we have one, and if A is larger than B, we have one triangle. In this case, we could end up with no triangle, okay? If A is acute and A is less than H, no triangle exists. If A is obtuse means larger than 90 degrees, between 90 and 180. A is less than or equal to B, there is no triangle. And in this case, you either get this small triangle or this in the entire triangle, the large one. In this situation, H is less than A less than B. Since A is larger than H, a triangle is created, but since A is smaller than B, it can swing to the left, and H can create a second triangle. SAS, side, angle, side, two sides, and the included angle results in one unique triangle. SSS, side, 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 three sides result in one unique solution and one unique triangle, as long as one side is always smaller than the sum of the other two sides. And now, the cosine law indicates that A squared equals B squared plus C squared minus 2BC cosine A. This is the included angle for the B and C. And so we are going to prove that shortly. Case 3, SAS, two sides and the included angle results in one unique solution and one unique triangle. Case number 4, three sides results in one unique solution and one unique triangle, as long as one side is smaller than the sum of the other two sides. This one requires cosine law. This can be done with the sine or cosine. Theorem: SSS has no solution if A is larger than or equal to B plus C. In other words, one side is larger than or equal to the sum of the other two sides. So A squared is B squared plus C squared minus 2BC cosine A. If you want B squared, you put A squared plus C squared minus 2AC cosine B. So that is the included angle, c squared would be a squared plus b squared minus 2ab cosine c. Now, if we look at this case, we can move the a squared to the other side, becomes negative, and we can move this to the other side, becomes negative, becomes positive. Now, if we want to solve for cosine, all we have to do, divide both sides by 2bc. And so we get cosine is b squared plus c squared minus a squared over 2bc. Now, the law of cosine generalizes the Pythagorean theorem, which holds only for right triangle. If you happen to have a right triangle, this is cosine of 90 degrees, which is 0. Everybody knows a squared equals b squared plus c squared, right? So if it's a 90-degree angle, this becomes 0. Cosine becomes 0, this becomes 0, and that works. So Pythagorean theorem, in essence, is a special case of the cosine law. All right, so having said that, we have the following triangle, A, B, C. We drop a perpendicular, we call it H, and this point we call it D. This distance, we call it X. This distance is C minus X. AB is the C, and we are going to go with the triangle ADC. We are looking at this one. Okay. So this is X, this is C minus X, this is C. So in this case, Pythagorean theorem says this side AD, which is X squared, plus DC squared, which is H squared, equals B squared. So in this triangle, we use Pythagorean theorem. Cosine A is the adjacent AD or X over the hypotenuse B. So this is from this triangle. Now we want to go to the other side, this one, BDC. And we're going to write the same thing, Pythagorean theorem. This side squared plus this side squared is equal to hypotenuse squared. So this side is C minus X, quantity squared. This side, H squared. This side, A squared. So this side, C minus X squared, BD, let me just write. So this is BD, everybody, as X was 80. Plus H squared equals A squared. Now, we are going to square this. This is C squared minus 2CX plus X squared. I hope you remember A minus B squared is A squared minus 2AB plus B squared. So with that being the case, this becomes C squared minus 2CX plus X squared plus H squared equals A squared. Now, X squared plus H squared. Let me erase my work. What do we notice? This is B squared, and X is B cosine A. Let's do that. So we're going to replace this one with this one, and we're going to replace the X with B cosine A. So it's very straightforward, everybody. And so that's the proof. A squared equals B squared plus C squared minus 2BC cosine A. And you can do this for any other side. You drop a perpendicular here, you drop a perpendicular here, and you prove this for any of them. Therefore, A squared is B squared plus C squared minus 2BC cosine A, and cosine A is B squared plus C squared minus A squared divided by 2BC, and this is the cosine law. All right. Using cosine law, we want to solve the triangle SAS. Of course, we know that this is 2, this is 3, this is 60 degrees. And using the cosine law, we are going to find c squared. Class, if a squared is b squared plus c squared minus 2bc cosine a, according to this, c squared must be a squared plus b squared minus 2ab cosine c. So take a look at this one. And if this is c, then this becomes a, okay, and this becomes a. That's all. And of course, cosine A becomes. So I hope you can see the transition from here to here. As far as you memorize one of them, you should figure out the other one. So again, c squared must be a squared plus b squared minus 2ab cosine c. So just replace it. 2 squared plus 3 squared minus 2 times 2 times 3 times cosine of 60 degrees. And cosine of 60 degrees is 1/2. This is 4. This is 9. These two cancels out these two, so it's minus 2. Two times 3, I mean. So one more time. 2 squared, 4. 3 squared, 9. Minus 2 times 3 times cosine of 60. Cosine of 60 cancels out one of the 2 times 3 is 6, so minus 4 and 9. 13 minus 6 is 7. Therefore, C must be square root of 7. Cosine A is b squared plus c squared minus a squared over 2bc. So b squared is 9. C squared is 7 minus a squared is 4. 2 times b, which is 3 times c, which is square root of 7. Just plug it. Obviously, the top 9 plus 7 minus 4 is 12, and the bottom is 6. Square root of 7. We get 2 over square root of 7. We rationalize, and we get 2 square root of 7 over 7. 2 square root of 7 over 7. Very straightforward, everybody. So if cosine A is 2 square root of 7 over 7, which is not a common angle or arc, we have to use a calculator. A must be cosine inverse of this number. Putting it into a calculator, you get 40.9 degrees. So if this is 40.9 degrees, added with 60, 100.9, subtracted from 180 to get B. So B is 180 minus the sum of these two, or minus 60 minus 40.9, and that becomes 79.1 degrees. Very straightforward, everybody. All right, we are going to move on. This is 79.1 degrees, everybody. Okay, we're going to use the cosine law. A is 4, B is 3, C is 6. We have all sides, and obviously you can go with this formula, which results in this formula, and find one of them. So if we want to stick with this, b squared plus c squared minus squared over 2bc, that's cosine A. So we have 3 squared plus 6 squared minus 4 squared equal divided by 2 times 3 times 6. We are using this formula, everybody. This is 9 plus 36 minus 16. We get 29 in the numerator. The denominator 2 times 3 times 6 is 36. And of course, another common arc. A is cosine inverse of this number. A cosine inverse of 29 over 36, which is 36.3 degrees. Now, if I want cosine B, okay, so I'm going to replace the B here, okay. So b squared plus c squared minus a squared becomes a squared plus c squared minus b squared. So because I want the b, so this becomes b, okay. A squared plus c squared minus b squared. What about the bottom? 2bc becomes 2ac because I want cosine of b. So I want to change this to b, okay. So we interchange these two, and this becomes a. So this is 36.3 degrees. This becomes A, and we are going to plug in. So let's evaluate. Sixteen 36 minus 9 is 43. 2 times 4, 8 times 6, 48. So if cosine is 43 over 48, then B must be cosine inverse of 43 over 48. Using a calculator, we end up with 26.4 degrees. So we put it there, 26.4 degrees. Add them up, subtracted from 180. 180 minus A minus B, that means 180 minus 36.3 degrees and minus 26.4 4 degrees. C, the last angle becomes 117.3 degrees. Again, you found two of them. Add them up, subtracted from 180. Pretty straightforward, everybody. We're going to move on. All right, solve applied problem. A boat leaves Naples for Key West. So from here, We want to go here. 150 miles away, the distance of 150 miles at 15 miles per hour. So we are going 15 miles per hour, going from Naples to Key West. That is the plan. It encounters heavy crosswinds and strong current. The crew finds after 4 hours later, that the sailboat is off course by 20 degrees. So instead of going this way, it's going this way, and this angle is 20 degrees, everybody. After 4 hours, going this way. So if we are doing 15 miles per hour, 4 times 15, so we have covered 60 miles in this direction, in a wrong direction, 20 degrees off, okay? How far is the sailboat from Key West at this time? So basically means from here to here, we want this distance of X, everybody. That's the meaning of it. So one more time. We want to move from here to here, Naples to Key West. We are going in a wrong direction by 20 degrees. 4 hours later, 4 times 15, 60 miles later, we notice that, and we want to go this way to Key West. The very first thing is we want to know what the distance is. If you look at this triangle, we have two sides, everybody, and the included angle, and we're going to use the cosine law. A squared is b squared plus c squared minus 2bc cosine A. So a squared here is x squared, everybody. So x is missing, x squared. Doesn't matter which one is b, which one is c. This side or this side. So 150 squared plus 60 squared minus 2 times 150 times 60 times the included angle, cosine of the included angle. So one more time. X is missing, so x squared. This side, 150 squared. This side, 60 squared. Minus 2 times the product of the two sides and the angle in between. Minus 2 times 150, 60 cosine 20. Put it into a calculator. It results in 9,185.53. That is x squared, everybody. So what is x? Take a root. 95.8, roughly 96 miles. Normally, they tell you how many decimals. If they don't, you carry many, many, many decimals. So x is found to be 95.8 miles, roughly 96 miles. Through what angle should the sailboat turn to correct its course? So we're going this way by mistake. So we have to go this way. That means we have to make some angle, and that angle is theta. So all you have to do, what is this angle theta? That's what the question is asking. Find the angle theta. That's all it's asking. Okay. So if we want to know this angle, and we call this angle A, if we could find angle A, then theta would be 180 minus A, right? So one more time, we want to find theta. If we could find A, then theta would be 180 minus A. And the reason we can, because if you go back to the triangle, all sides are known now. So this is 60, everybody. This is 150. This is almost 96, 95.8. If we have all sides, we can find all angles. Of course, one of them is 20 degrees, but this is what we want. We want A. So cosine A equals b squared plus c squared minus a squared divided by 2bc. You can use that formula, or just a squared equals b squared plus c squared minus 2bc cosine and get 2 cosine. It makes no difference. In essence, these two are really the same, okay? And so since you want a, the side opposite that, 150 squared, would be this one squared and this one squared, 95.8 squared plus 60 squared minus 2 times the product of the two and cosine A. So 150 squared, the side opposite A, is the other ones, 95.8 squared plus 60 squared, and then minus 2 times the product of the two cosine of the included angle A. Or like I said, just put it into this formula, b squared plus c squared minus a squared over 2bc. Either way, you go through the process, you find cosine A. So you can subtract this two from the left side, you get this number. Cosine A is the number 9,684 divided by negative 11,520, and cosine A becomes negative 0.8406. So what is A? Cosine inverse of this number. And that's 147.2 degrees from a calculator. What did we want? Theta. What is theta equal to? 180 minus A. Theta is 180 minus A. So 180 minus 147.2 gives us 32.8 degrees. So theta is 32.8 degrees. How much time has been added to the trip because of this? Assume the speed remains at 15 miles per hour. Well, the distance is supposed to be 150, but now it's 60 plus roughly 96 or 95.8. So this total distance, if we subtract the 150, it shows how much we've added. So added distance is the sum of these two numbers minus what we need. We had to go 150 miles. So the difference is 6 miles. So divided by the rate. So T is D over R, 6 over 15. That means 0.4 hours. You can multiply this by 60, you get 24 minutes. So 0.4, you multiply it by 60 to get 24, right? Because 1 hour is 60 minutes. Example 4, an airplane flies due north from Fort Myers to Saratoga. So we want to go Sarasota. So from here to here, a distance of 150 miles. And then turns through an angle of 50 degrees. So we are going this way through an angle of 50 degrees. We go this way for 100 miles and flies to Orlando, a distance of 100 miles. How far is it directly from Fort Myers to Orlando? So in other words, we are going to go this way 150 miles. We're going to go this way 100 miles. But what if we wanted to go straight? How much would that be? That is the question, everybody. So let's call this A. This is 50 degrees, everybody. So what is this angle? Clearly, This angle and 50 degrees must add up to 180, must be 130 degrees. A squared is b squared plus c squared minus 2bc cosine A. So A squared is 150 squared plus 100 squared minus 2 times 150 times 100 times cosine of 130. You put that into a calculator, it gives you A squared equals 51,783.554, and A is the square root of that, everybody. 227.56. So you have to take the square root of this. And you get this one, and you write A, the distance is 227.56 miles. What bearing should the pilot use to fly directly from Fort Myers to Orlando? So we want to go straight to Orlando. What bearing? I hope you see that this is north, this is east, and whatever this angle is. So let's call this B, angle B, which we don't have, we don't know. And this is north, B degrees east. So there are a couple of ways to handle them. Again, A squared equals B squared plus C squared minus 2bc cosine A. In this case, this is the included angle. These are the two sides, and this is the one that is going to be your A. Are you with me? In essence. So this side squared, 100 squared. Now this is the angle, the two sides by the angle. This one is squared plus this one is squared minus 2 times this one times cosine of B. So 100 squared, the side opposite B. Now the two sides, 150 squared plus 227.56 squared, then minus 2 times the product of the two, 150 and 227.56, and cosine B. So this is one way to do that, and I'm going to assume everybody can easily finish that. The other one is that we don't have B, we have the opposite side. We also have A and the opposite side. So we can use the sine law and say sine B over 100 is sine of 130 over A, which is 227.56. So you have two ways of calculating this. And I'm going to leave it for you to calculate them. I will give you the answer. Okay. Through these methods, you can find either sine B or cosine B, either way. So if you go with cosine B, you get 0.9415 if you go this route. So what is B? Cosine inverse of this number, and the calculator indicates is 19.7 degrees. I highly recommend you try this one as well. You should come up with the same answer. Therefore, if this is 19.7 degrees, then we're going to say north 19.7 degrees east. North 19.7 degrees east. Let's look at this situation. Example 5. Flying from Chicago to Louisville, 330 miles. So Chicago to Louisville is a distance of 330 miles. A pilot carelessly took a course that was 10 degrees off. So instead of going this way, we are going the wrong direction by 10 degrees. in error. If the aircraft maintains an average speed of 220 miles per hour, and if the direction is discovered after 15 minutes. So we are going to go for 15 minutes at 220 miles per hour. Then through what angle should the pilot turn to head toward Louisville? So to fix the problem. Well, first we need to figure this one, and then we want to answer this one. So this is angle B. This is 180 minus B. So we need to find B. Let's find angle B. And then the answer would be 180 minus that. This distance, let's just call it something C. And we know that D equals RT, right? Everybody remembers that D is the distance, R is the rate, T is the time. So what is our rate? We are doing 220 miles per hour. This is R, everybody. For how long? 15 minutes. 15 minutes is 1/4 of an hour. So to be exact, we're going to write 15 over 60. Of course, 15 over 60 is 1/4. But if it wasn't, whatever this number, divide by 60 in order to change to the hours. The 0 drops here. 15 is divisible by 3. So is 6. 22 and 2 is 11 times 5, 55 miles. Therefore, we are covering the distance of 55 miles in a wrong direction. So let's call this something. For example, this distance is A, and we're going to use A squared equals B squared plus C squared minus 2BC cosine A. We want to find all sides, right? So we have this side, this side, this side, then we can find all the angles. And so to do that, A squared is B squared plus C squared, the sides. So whatever side that 330 miles per hour, 330 squared plus 55 squared minus 2 times the product of these two numbers, 2 times 330 times 55 times cosine of the included angle, cosine of 10 degrees. So this side squared plus this side squared minus 2 times the product of the two sides and cosine of the included angle. You put it into a calculator, gives you an answer. You take a root, and A becomes almost 276 miles. I recommend you put quite a few decimals if they don't ask you, okay? So now what do we have? We have all sides. We have this side, we have this side, we have this side. So A is 276 miles roughly. B, let's say this side is 330 miles, and C is 55 miles. So in order to find the angle B, then A squared equals B squared plus C squared minus 2BC cosine A pertains to this side. 330 squared is this side squared plus this side squared minus 2 times the product of the two cosine B. So this side, 330 squared is 276 squared plus 55 squared minus 2 times 276 times 55 times cosine of B. So you solve for cosine B by putting everything into a calculator. You end up with negative 0.978. B is cosine inverse of this number. about 168 degrees. So if B is 168 degrees, what we are looking for is 180 minus that, 180 minus that, which gives us 12 degrees. What new average speed is needed to keep the total time of the trip at 90 minutes? Let's say the idea was that we want to go from here to here, 90 minutes, but we went wrong. We went the wrong way, so we added some to the distance, but we want to still keep it at 90 minutes. That means whatever speed we were going is not going to cut it anymore. We have to go faster by a little bit. How much? That's what we want to know. To do so, if we want to keep it at 90 minutes, we already covered 15. So what do we have left? 75 minutes. So we want to go this distance over the course of 75 minutes, which is 60 plus 15, which is 60 plus 1/4, which is 1.25 hours, because this is miles per hour, everybody. So you want to change this to hours. D equals RT. R is D over T, and the distance we're talking about is 8. A is 276 miles, and the T is 1.25. And so roughly 220.8, roughly 221 miles per hour. Again, as far as the number of decimals, class, you just follow what they tell you, okay? A quick recap. So we want to go from Chicago to Louisville. We make a mistake of going off by 10 degrees, okay? And we are doing 220 miles per hour over the course of 15 minutes. That means we cover 55 miles. So we have this side, we have this side, we have 10 degrees. We can find all sides, and we can find this angle. When we find this angle, the question is, what is this angle, which is 180 minus that? And when we have all sides, we can divide this distance by the time left, 1.25, to find the new speed. A radio tower 500 feet high is located on the side of a hill with inclination to the horizontal of 5 degrees. How long should two guide wires be if they are to connect the top of the tower and be secured at 2 points 100 feet directly above and directly below the base of the tower? Let's do the drawing here. So this is 100, this is 100, this is 15 degrees, this one is 500, and these two sides, we call them X and Y. So we are redrawing this. This is 5 degrees, this is 100 feet, this is 100 feet, this is 500 feet. What is this side? We don't know. What is this side? We don't know. We call them something, X and Y. So we are defining our variables to make it nice and easy to do the math. So if we look at this one, remember this angle is 5 degrees. So let's make it larger so it becomes clear. This is 5 degrees and this is 90 degrees. Means this must be what? 85 degrees, right? Because they must add up to 90 degrees. So Now, if this angle is 85 degrees, then this angle adding to 85 degrees must be 180. So this must be 180 minus 85 or 95 degrees. Now, if this is 95, of course, you can say these two lines, so this becomes the same as this one, or add subtracted from 180. This is also 85 degrees. So first, I'm hoping that everybody is following the angles. Now, in each case, we can say a squared is b squared plus c squared minus 2bc cosine a. So if we are interested in x, so what is x squared? Well, let's go with this one. So you're going to say 500 squared plus 100 squared minus 2 times the product of the two and cosine of 85 degrees, right? You're going to work it out, take a root, and x becomes 501.28. Again, it's at this point, the idea is to be able to set it up, then the rest becomes elementary. Now, what about y squared? We are going to use this one, everybody. And say, okay, we want y squared. So this side is squared 500 squared plus 100 squared minus 2 times the product of the two times cosine of 95 degrees. And again, you put it into a calculator and you come up with the answer. You have to take a root. Y is a little bit longer, 518.38 feet. Draw and solve the triangle A is 8, B is 3, and C is 6. So we have all sides, side angle. So just use either this one or that. Remember, this is coming from this one. So cosine is B squared plus C squared minus A squared over 2 BC. So cosine A is B squared, 3 squared or 9, plus C squared, 6 squared, minus A squared, 64, 2 times 3 times 6. 936, 45 minus 64 is negative 19. 2 times 3 times 6, 36. And A is cosine inverse of this number, everybody. Putting it into a calculator, 121.86 degrees. Now another one, for example, cosine B is A squared plus C squared minus B squared over 2AC. So this one. So this side squared is 64, this side squared is 36, minus this side squared is 9 over 2 times 8 times 6. 64 and 36, 100 minus 9 is 91. 2 times 8 times 6 is 96. So B is cosine inverse of that. Putting it into a calculator, You get 18.57 degrees. Finally, you add these two, subtract it from 180. So A is 121.86, B is 18.57, C is 180 minus the sum of these two, which is 39.57 degrees. So in other words, C was 180 minus the sum of A plus B. It's very simple. Find the area of a triangle given three sides. How do we do that? Find the area of a triangle with the sides 3, 4, and 5. Well, we use Heron's formula. Finding area of a triangle given all three sides, the formula is the area equals the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2. That means if you look at the numerator is the perimeter, that's why they call it a semi-perimeter. So half of the perimeter. So add them up, 3 and 4 and 5, and divide by 2. 7 and 5, 12 divided by 2 is 6. Now putting it into the formula, so you put 6 here, 6 minus 3, 6 minus 4, 6 minus 5. This is 3, this is 2, this is 1. Their product is 36, and as you know, square root of 36 is 6 centimeters squared. Now, in this particular question, I wanted to, actually, I picked it on purpose to make a point, and the point is, notice that 3 squared plus 4 squared is 5 squared, right? 9 and 16 is 25. So it's, because it follows that, it must be a right triangle. Looking like that. The two sides are 3 and 4, and the hypotenuse must be 4. Okay. So why is this important? We know area is 1/2 base times the height. So 1/2. The two sides are considered based on the height, right? 3 times 4, and you get to the same answer. So it was in essence showing that Heron's formula does work, everybody.